Hello friends, welcome everyone to Smart Engineering Academy. Myself Amit. So I'm here with the continuation of geotechnical engineering topics where I'm going to start a new topic, that is seepage analysis. Almost I had completed 5 units previously in geotechnical engineering, and in this session I'm going to complete seepage analysis. I'd like to take some 2 to 3 videos for complete analysis of this topic, including MCQs. Fine. So first of all, coming into the exam point of view, this is most important thing. Normally there will be one question from this seepage analysis topic, some seepage analysis, then permeability, then bearing capacity of the soil, then lateral earth pressure. All these units are very important. This is one of the important topic which I am going to discuss it now. First of all, what is seepage? Seepage is nothing but a phenomenon of movement of fluid through the permeable medium. For example, if you take a dam section, okay, if you take, let me consider this as a upstream side and this as a downstream side. The water which is present in the upstream side, inside the dam, it is going to percolate because of the permeable medium. For example, if the dam, either it is made up of concrete dam or earthen dam is made up of soil, all these type of things are permeable in nature. That is the reason the water which is from the upstream side is going to seep into the dam structure. That is what the seepage is. And in this unit we are going to analyze like what are all the types of seepage that is going to take place in the dam structure. That is because dam is a very important construction in which the failure of dam happens due to the seepage. That is the reason we need to know the seepage which is going to take place in the dam, which are all the points and what are all the type and conditions and the boundary conditions that is going to take place. Let us study one by one. Okay, first of all let me just a minute. First of all, let us study the dam structure and what are all the types of seepage that is going to take place. See here, this is a dam structure, you can see here, and this is the upstream side of the dam in which water is present here, and this is the downstream side of the dam. And I'm just going to show you, see, I'm just marking it in the red, and I am marking these lines in the green. So what is the difference between these two lines? Red line indicates flow line and the green line indicates equipotential line. So what is the difference between these two? What is flow line and what is equipotential line? First of all, the flow line is the path traced by the individual water particle. See here, there is a water in the upstream side in which the water is getting seepage or getting percolated through this point, and it is moving in this direction and it is reaching the downstream side of a dam. Okay, this is one path and this is the second path. Okay, there may be some more paths, 3, 4, 5, 6, depending upon the boundary condition. There will be many paths, and the path traced by the individual water particle, this is the first path, this is the second path, and this is the third path, and the path traced by the individual water particle is called as flow line. Then what is equipotential line? What is equipotential line? Is a line which is drawn perpendicular to the flow line. Equipotential line is drawn perpendicular to the flow line, so that the equipotential line shows the similar head. Okay, each equipotential line shows the similar head. Means if you are placing some piezometer here and if you are placing the piezometer in the same thing, the head will be, the rise in the head will be same. Okay. So that is what the equipotential line is. Let us go through the concept. So by considering the same potential head, we are going to draw the equipotential lines. So as I told, flow line, the path traced along which a water particle travels, and it is, the flow line is also called as streamline. Fine. Path traced by an individual water particle, which I had explained in a very detailed manner. Then what is equipotential line? It is a line joining the points that is having equal total head. Okay, in this equipotential line, all the lines which is drawn in such a way that it should have equal potential head. Just if this is flow line and if this is equipotential line, the equipotential line is drawn in such a way that if you are going to place some piezometer here and one more is here, it shows the same head difference. And again the same thing in this also, so that in the individual line which is traced here, it contains the same equal head. That is what the equipotential line is. So what is the importance of equipotential line? That I am going to explain in the upcoming slide. See, the same thing what I had explained is told here. If the piezometers are inserted into the soil at the different points along the equipotential line, water would rise at the same elevation in all those parameters. This is if you are placing the piezometers in the same equipotential line, you are going to see the same head difference in the particular equipotential line. Fine. Then they have given some note. Along a potential line, equipotential line, the total head is constant. Okay, in the equipotential line, the total head remains constant. While the pressure heads are different, elevation heads are different. Okay, just make a note of this point. Then what is Flownet? Flownet is a combination of flow lines and equipotential lines. That is, if I am going to draw a dam section here, and if this is the flow line and if this is the equipotential line, okay, it is combinedly called as Flownet. It is a combination of flow lines as well as equipotential line. The combination of these two things is called as Flownet. Next, what is flow path? I'll just show you. If I am drawing flow lines here, if I am drawing a flow lines here, the space between the two adjacent flow lines is called as flow channel. See, this is one flow channel, this is other flow channel, other flow channel, other flow channel. There are 4 sets of flow channels. Flow channels is nothing but the space between the two adjacent flow lines is called as flow channels. Then what about field? For field, I'll just show you. If this is flow line, if this is equipotential line, this is called as field. Field number 1, field number 2, field number 3. Space between the two adjacent flow lines and adjacent equipotential lines is called as field. This is called as field. All these things are field. It is a adjacent things which is, you can see here, is a field. Normally the shape of the field always it will be square. Please make a note of this point. Fine. Next, what is the characteristics of Flownet? Let me explain you one by one. Again, flow lines and equipotential lines. Characteristics of Flownet. Flow lines and equipotential lines are orthogonal to each other. You know, the green line which I have drawn here is a flow line, and the yellow line indicates equipotential lines. Always these two things are drawn in such a way that it is perpendicular to each other, nothing but orthogonal to each other. The quantity of seepage in each flow channel is same. Okay, you can see. So this is one flow channel. flow channel. Adjacent line between the two flow lines is called as flow channel. The quantity of seepage in each flow channel is always same. Drop in head between the adjacent equipotential line is same. Suppose this is one equipotential line, first equipotential line, second, third, fourth. The drop in head between the adjacent equipotential lines is always same. For example, if I keep one piezometer here, the rise in head is take 22 centimeter. Then here it will be 20 centimeter. So what is the drop in head between these two things? It is 2 centimeter, right? In the same way, if you go here, it will be rise in head will be 18 centimeter, and the drop in head between these two equipotential line is again 2 centimeter. That is what they are telling. Drop in head between the adjacent equipotential lines is always same. Drop in head again, if you come here, there will be 2 centimeter drop in head from one equipotential line to other equipotential lines. Then what is the next characteristics? Two flow lines or equipotential line can never meet or cross each position. That means flow lines, equipotential lines. Two flow lines or two equipotential lines can never meet or cross each other. See, there is a different distance between these two things and they will never meet. Okay, they will never meet and they will never cross each other. Never meet means this first one and second one, they will never meet. Never cross each other means it will not cross like this. It is wrong. It will be like this one. Fields are kept approximately square. This is already I told you, all the fields. This is nothing but a field 1, field 2, field 3. Almost it will be kept in a square. This may be a objective question. Flow net does not depend on permeability. See, all this flow net will not depend upon the permeability of the soil and head causing the flow. All these things are mainly dependent upon the boundary condition of the place. Okay, this would be a MCQs. They may ask flow net does not depends on. It will not depend on permeability. It will not depend on head causing the flow, but the flow net is going to depend only upon the boundary condition. Please remember this point. All these points are very important. This will be asked in MCQs in such a alterations. So this is all about the characteristics of flow net. Fine. This is one concept. Let us move on to the next. So what is the uses of flow net? Okay, just I am brushing you up. What is flow net? Flow net is nothing but a combination of flow lines and equipotential lines. What is flow line? Flow line is a path traced by an individual water particle. What is equipotential line? Equipotential line is drawn perpendicular to the flow line so that it gives the constant head. Okay, so what is the uses? That means if you're taking a dam section here and if you're drawing flow lines and equipotential line, what are the uses? Why are you drawing it simply? What is the use of drawing this flow line and equipotential line? The main use, there are 4 number of uses for drawing the flow net. First one is seepage loss. To find the seepage loss, the water which is present in the upstream side and some of the water is present in the downstream side. The water, due to the seepage, it is going to get lost. So the amount of loss, the quantity of loss that is taking place because of this is we are going to find. That is the first use of flow net. Second, seepage pressure. Seepage pressure at a point. See, let me take this as point number 1, point number 2, point number 3. In every point you can see the seepage pressure. What is the amount of pressure of seepage that is taking place? That is the second use. Third use is uplift pressure. Uplift pressure at a point. What is the uplift pressure that is going to take place? What is the exit gradient? At the exit, this is the entry point and this is the exit point. Normally we are going to give a drainage system here, and if this is the exit point, we need to construct a dam in such a way that we have to give the exit gradient, because it is very important. Otherwise what happens, the water which is entering here, it is going to exit here, and it will come and join the downstream side, because this is the critical area. If you are not going to give the proper gradient, then what happens at this point, the failure of dam section takes place. That is the reason we have to give the exit gradient. So these are the 4 uses of the flow net, and here you are supposed to make use of these 4 concepts, in which normally MCQs are going to ask, and there will be numericals and sets of formulas you are supposed to learn in this flow net. Let us move. First, seepage loss, seepage quantity. That is, by just drawing the flow net, you are going to find, you are going to find the seepage quantity, amount of seepage that is taking place in the dam section. So the formula for that is, seepage quantity is represented in terms of Q, which is equal to K into H into NF divided by ND. So what is K? K is permeability of soil. Okay, K is permeability of the soil. What is head? Okay, H is net head causing flow, that is the difference between upstream and downstream water levels. How to find the value of H? For that, I'll just draw you the dam section. Okay, so I will take this as H1 in the upstream side, and here of course the level of the water will be less compared to upstream side in the downstream side. Let me take it as H2, and this height, what we will call it as H, which is nothing but this H, that is net head causing flow. This capital H will be equal to H1. Okay, H1 is nothing but height of the water in the upstream side minus H2, the height of the water in the downstream side. By this we can calculate the value of net head causing flow. That is how you are going to calculate. Then number of flow lines. This NF is nothing but number of flow lines. Number of flow lines means, for example, okay, the total in this figure we can say 1, 2, 3. The total number of flow lines is 3. Then ND. ND is nothing but number of potential drops. Okay, that is, if you take equipotential line, number of potential drops will always be equal to number of equipotential line minus 1 will be your number of potential drops that is going to take place. And this NF by ND, which you can see here, this NF by ND is also called as shape factor of the flow net. For the given boundary condition, the NF by ND ratio remains same. For the particular set of boundary condition, the flow net will be unique. In some of the condition it will be unique, but NF by ND is also called as shape factor. This is how we are going to find the seepage quantity. That is the first use of the flow net we have seen. Let us go into the second use of the flow net.